Okay, so today we're going to start section 1.2 on estimation. And before we start working these problems, let's define estimation. Estimation is basically rounding numbers before we perform a calculation. Okay, so let me stop sharing so you can see what I wrote. Estimation is basically rounding numbers before we perform a calculation. Okay, so that's what we're going to do here in section 1.2. We're going to round the numbers first before we perform a calculation. So sections 1.2 and 1.3 are problem solving, sections on problem solving. So let me share my screen here so you can see the workbook. And as it is my practice, I will do a few problems so that you have a model. I won't do every single problem in the workbook. You have the answers in the back of the workbook. In case you want to work all of them, I encourage you to do all of the problems of every section. But for the sake of time, I'm not going to cover every single problem. I will just give you a model so that you have something to guide you, right? So let's begin. Excuse me. Number one, it says estimate the total cost of 9 high intensity LED light bulbs on sale for $12.99 each. Give your answer in whole dollars. Well, this problem is not difficult to solve because we can estimate and say, well, instead of using $12.99, I'm going to use $13 per each light bulb, right? So I can do that. I can round to $13 and I want to purchase 9 of these light bulbs, so I can multiply 13 by 9, right? So I can just times 9 and then get an estimate, and I can do this by hand. I don't have to, let me stop sharing so you can see. So I don't have to use a calculator for this, so I can simply multiply, right? So if you want to do it like this, like this, we multiply 9 times 0 is 0, 9 times 0 is 0, 9 times 3 is 27, there's 2, 9 times 1 is 9, and 2 is 11, right? So you see that it will cost us about $117, right? Now, there's nothing wrong with using your calculator. So if you want to double check with a calculator just to make sure you did it right, right? So 13 times 9 gives us $117, right? So that, that's an estimate because we rounded $12.99, we rounded it to 13, okay? So that's one way to solve this problem. So that's number one, excuse me. And, when you're working these problems, always check to see if it makes sense. So when you're working these problems, it should make sense. The answer should make sense to you. If you come up with a number that totally does not make sense, then, just go back and check the answer, because maybe you made a mistake somewhere. All right, let me share my screen now so we can move on to the next one. Okay, so let's see. Problem number 2, I usually work the odd numbers, but let me go ahead and do this one to number 2. It says estimate the time it would take you to drive 197 miles at 41 miles per hour and round to the nearest hour. So we can use the formula for, and if you scroll down here to one of the problems here, it gives you the formula for speed, right, number 7. So you write speed equals distance divided by time. Or you can also use distance equals speed times time. You use either or. There's different ways to solve for, depending on what you're looking for. If you're looking for distance, you can solve for distance. If you're looking for time, you can solve for time using the same equation. So if you go to number 2 here, it says, estimate the time it would take you to drive 197 miles. So I'm going to write this down, 197 miles. I will stop sharing right now once I write down the information at 41 miles per hour. So my distance, I can write distance equals 197 miles, and then the speed is equal to 41 miles per hour. And then it says to round to the nearest hour. Now make sure you don't forget to round, because if it's telling us to do this, we should, And so let's see, let me stop sharing. And we're looking for how long it's gonna take us, right? So there's the formula, but I'm looking for time. So you can, instead of using, well, you can use the formula the way it's written, right? Or just solve for time, because I want to know time. So time is what I'm looking for. So I put a question mark here. And so you can plug in the information that you know. So if I use this formula, speed equals distance divided by time. So I'll use red for the time because that's what I'm solving for. And, the speed is 41, so I'm going to plug that in. And the distance is 197 miles, and I'm looking for time. And so this is, if you were going to solve this with just, the usual way of solving for solving an equation for the unknown, well, time is the unknown, right? So you can multiply both sides of the equation by the unknown to get rid of the unknown on the right side, right? And this will get rid of time. And then we have 197, and then we have time here times 41. Well, then divide by 41, right? Both sides, so you can get rid of the 41. And then so time equals 197 divided by 41. And remember to round to the nearest hour, right? And so we get 197 divided by 41. And we get 4.8 something. So about 5 hours, right? Because we have to round to the nearest hour. So 5 hours. Now this is if I solve the problem with the, with the given numbers, right? But remember, this section is talking about estimation. So another way you can solve this one, and using the estimating first, is you can estimate distance, and instead of 197 miles, you use 200, right? And for speed, you use 40. And then you solve the same way. You plug in these numbers, right? And you solve for time. And so as you can see, time, right, is equal to the 197 divided by 41. So instead of using 197 by 41, we can use 200, right, divided by 40. And we still get 5, you see? So round this to 200, 197 divided by 40, and you get 5. Okay, so it's 5 hours. Okay, so remember, we're supposed to round here, but I wanted to show you like what it would be like to solve it with the given numbers, and then you can, once you get to this point, you see how if we were to round, we would end up with 5 anyway. So 200 for 187 and 40 for 41, you divide the 2 and you get 5 hours. Okay. Okay, so that's number 2. Go back here to the questions. And let's look at number 3 here. I'm gonna do number 3 also. Number 3, it says, if Aaron earns 33,957 per year, so you can probably round to 34,000, right? So let's go ahead and round. So let's say that Aaron is making 34,000 per year. Estimate how much she earns per hour. So we want to know how much, let me write down what we're looking for. Does she earn per hour? Right? How much does she earn per hour? Now, we're going to make an assumption that she works 40 hours per week. So she works 40 hours per week. Okay. And 50 weeks per year. Okay, so and 50 weeks per year. So she only takes 2 weeks off in a year. Round your answer to the nearest dollar. Okay, so round to the nearest dollar. Okay, so let me stop sharing so we can see. Okay, so she's making 34,000 per year. We want to know how much does she earn per hour. Okay, so we know that she works 40 hours per week, right? And she's working 50 weeks per year. And so if you have 34,000 per year, right? And so we want to get how much she earns per hour. So we have to see how many hours. So the total number of hours, because that's what we're interested in, earned per hour, right? So total number of hours in a year that she's working, we need to figure that out. So she works 40 hours per week. So 40 hours per week times 50 weeks, right? She works 50 weeks. So how many hours? That's 40 hours per week times 50 weeks. She's working 2,000 hours in a year, right? And she's making 34,000 in a year. So if we take 34,000, I remember we're estimating divided by 2,000, right? 34,000 divided by 2,000, we can get $17 per hour, right? So there's another way you can do this, but I think this is straightforward. I mean, just figuring out how, because we're looking for how much she's making per hour. If we just can't find, if we can find first how many hours she works in a year, and we can do that because they're telling us she's working 40 hours per week, and she's working 50 weeks out of the year. So 50 times 40 gives me total hours that she works. So she's working 2,000 hours in a year, and she's making 34,000. So basically, another way you can do this is just, remember the zeros cancel here. So 34 divided by 2 is 17. And, she's making $17 an hour. Okay? That's number 3. That's one way you can solve this problem. Okay. And let's see. So I'm gonna go ahead and do number 4, number 5, and then I'll do one of the graphs because I know you have some graphs. I want to get to number 5 because that one is not like, I want to show you how to solve that one. Let me just drink some coffee here. So I hope this is making sense to you. Okay, so let's do number 4. It says, number 4 says, estimate the cost of putting up a decorative border in your family room if your room is 20 feet long in your family room. Okay, so we have a family room that is 20 feet long and 12 feet wide. 26 feet long and 12 feet wide. And the border costs $8.95 for a package containing 10 feet. So $8.95 for a package that contains 10 feet. So we need to figure out how much material we're going to need, right? So basically you can draw the picture. Let's see, you don't need to draw the picture. I recommend it though. So you have 12 feet, 26, right? So you have to see, okay, so how much, what is the total perimeter here? You want to find the perimeter, right? By adding all the sides. And so we have 26 plus 26 plus 12 plus 12 gives me 26 plus 26 plus 12 plus 12, 76 feet. And one of these packages covers 10 feet, right? So you will need, when you divide 76 feet divided by 10 feet, right? To see how many of those you're going to need, you get 7.6, right? Well, you can't buy 7.6 packages, so you're gonna need 8 packages. So you will need 8 packages, right? And if we estimate that to $9 each, you can multiply 8 times $9 each. It's gonna be $72, right? For the material that you will need to cover everything. Okay, so once again, I mean, if you can't buy 7.6 of those, so you will need 8 of them. If you estimate at $9 each, 8 times 9 equals $72 for the 8 packages you need. Okay, so that is number 4. That's number 4. And then we move on to number 5. This one, I was like, how do I do this one so that I can show them an easy way to solve it? But I had to actually draw something. It wasn't the best picture. So I'll show you, but let's read it together. The Tea Party at a large university plans to line both sides of a 52-foot long hallway with posters endorsing a candidate for state senate. Each of the posters cost them $4.95. They're 3 feet wide, and there will be 4 feet between posters. So you have like, each poster is 3 feet wide, and then you gotta leave a space of 4 feet between each poster. Assume the first poster on each end will be exactly even with the start of the hall. Estimate how much will it cost. So we first have to figure out how many posters we need, because each one is we can round it to $5 each. But how many do we need to cover the entire hallway, right? It's both sides, 52-foot long hallway with posters, and we need to do this both sides. So the way I did it, I'll show you. It's not hard once you see it, but you need to kind of see it. It did take me a little bit of time, okay, to know what I needed to do here. So what I did was 4, 5, 6, 7, 8. I went ahead and did, okay. I said, well, I'm gonna do two rows like this, as if I was placing these posters, right? And I know, depending on what I need to cover 52 plus 52 is 104. So I did 8 boxes like this. I'll explain why. And then I shaded. This is what I did. It's like, it's continuing, okay? So it's like, it doesn't stop. It's one side and then the other side. And 1, 2, 3, 4, 5, 6, 7, hold on. Yeah, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8. So I did 8. 1, 2, 3, 4, 5, 6, 7, 8. And then over here I did 1, 2, 3, 4, 5, 6, 7, up to 7. So don't count this one. Let me try Don't count the last one, okay? I'll show you why. And because you don't need this last one, so this one, I don't have a whiteout, so just don't count that one. So this one say 3 feet, because that's what the posters are, right? 3 feet, 3 feet, 3 feet, 3 feet. And then, okay, and then 1, 2, 3, 4, 5, 6, 7. This one has to be shaded, so this one is shaded, okay? The last one here is shaded. And remember, this is not here, this one, so ignore this one. Okay, 3 feet and 3 feet. And then between is 4 feet. Remember, you need 4 feet of space between them. Now you see, when you count this, it should give you, because you go ahead and count. So okay, you have 3, that's 7, 10, 14, 17, 21, 24, 28, 31, 35, 38, 42, 45, 49, 52. So you cover 52 feet, okay? Which we needed that. So that's exactly what I need. And then you count how many posters is it. So it's 1, 2, 3, 4, 5, 6, 7, 8. But remember, it's both sides, so it's 16 posters. So 16 posters I will need at $5 each. So that's gonna be $80. Okay? Because remember, you need to do this both sides. All right? So that's one way you can solve this problem. And that's number 5. Okay? And so you will need about $80 to pay for this. That's the estimated cost, and you need 16 posters. All right, so that's number 5. Let's see. What else do we have here? I want to do one of these things. Let's go to number 9, because we have to do not just problem solving, we also need to interpret graphs. So I'll do number 9 to give you a model. And let's read it together. It says, use the information shown in the graph. The graph represents a survey of undergraduates enrolled at local college in the previous academic year. Okay, so that's the previous academic year. Hours per week worked by college. So these are, okay, so these are college. The graph represents a survey of undergraduates. So these are college students that are working, and as they're going to school, they're also working. And so we have, if we look at the graph here, 16.3%, they work up to 10 hours. Between 21 and 30 hours, 38.8%. 11 to 20 hours, 25.9%. And 31 or more hours, 19%. And the first question here, it says approximately what percentage of the students work more than 21 hours per week? So more than 21 hours per week, that means, let's take a look at the graph. So more than 21 hours per week, and we want to round each term to the nearest whole percent before calculating your answer. So it's telling us to round each of them to the nearest whole percent. Okay, so more than 21 hours, it would include categories 21 to 30 hours, right? So round each term to the nearest whole percent. So that's 39%, right? The 21 to 30 hour category. And also the 31 or more hours, so that's a 19%. So if we add the 2, that's going to give us 58%. So for answer A, approximately 58% work more than 21 hours per week, right? So let me stop sharing here. So that's for part A, more than 21%, sorry, more than 21 hours per week, you have 39% and 19%. When we add the two, we get 58%. Okay, so that is the answer to part A. And let's see, part B, it says, if 5,000 students were enrolled at the college the previous academic year. So we have 5,000 students enrolled. Okay, so that's in total. It says, how many work 31 or more hours per week? Well, 31 or more hours, that's 19%. So you can estimate, you can do 5,000 times 19%, or you can do 5,000 times 20%, just round it up, to 20%. You can do that. And so, because it's 31 or more hours, you see it's 19%. So if we multiply 5,000 times 19%, we get 5,000, 5,000 times 19%, we get 950, right? 950 students. So I think we can just, because the instructions are to round to the nearest percent, I don't think we need to round here to 20%. So we can just calculate it based on the 19%. Now notice something that I went ahead and multiplied by 0.19 because 19%, when I write it in decimal form, it becomes 0.19, right? So for example, remember that 19%, if you want to convert to decimal, you write 19 divided by 100, and that moves the decimal 2 places to the left, so it's going to be 0.19, right? So if you multiply 5,000 times 0.19, it gives you 950 students. So you have about 950 students out of the 5,000 students working 31 or more hours per week, okay? That's the answer to number 9. So the answer to number 9 is 950 students. All right, so let's see, you have 10. Okay, so you can do the rest. I did most of the problems for you, so I think it's only 2 of them that I left. So you can try those. And the next video will be on problem solving strategies. And really, it's more problem solving. There's no right or wrong way to solve problems, mathematical problems. It depends on a lot of it. Many people see it one way, other people see it a different way. So I'll show you one way to do it, and I'll go through some of these problems to help you. And so I will see you on the next video. Thank you so much. God bless. Bye-bye.